Question. Consider the polynomial px is equal to x square plus bx plus c, where b and c are integers. If px divides both x4 plus 6x square plus 25 and 3x raised to the power 4 plus 4x square plus 28x plus 5, then what possible value can P1 have? Answer. Px is x square plus bx plus c. Let P1 be x4 plus cx square plus 25 and P2 be 3 raised to the power of 4 plus 4x to the power 2 plus 28x plus 5. It is given that Px divides both these expressions P1 and P2. Since Px divides P1, Px also divides R into P1, where R is any arbitrary integer. Similarly, since Px divides P2, it follows that Px also divides S into P2, where S is another arbitrary integer. Since Px divides both R into P1 and S into P2, we can say Px divides R into P1 plus S into P2. Because R and S are arbitrary, we can assign any integral value to them without loss of generality. Let us assign R is equal to -3 and S is equal to -1. This is chosen specifically by us to make the x to the power of 4 terms cancel out, as will be clear below. If you do that, then R dot P1 plus S dot P2 would become, replacing R by -3, we get -3 x raised to the power of 4 minus 18 x raised to the power of 2 minus 75 plus, putting x is equal to 1, we get 3 multiplied by x raised to the power of 4 plus 4 multiplied by x raised to the power of 2 plus 28x plus 5, and that is equal to, if we rearrange terms, the the x4 terms will cancel out and other terms will become minus 14 x to the power of 2 plus 28x minus 70. Dividing this expression by px, we get, by long division, minus 14 x raised to the power of 2 plus 28x minus 70 whole divided by px, which is x raised to the power of 2 plus bx plus c. And by long division we get a quotient of minus 14 and a remainder of this term. Since px should divide the expression r dot p1 plus s dot p2, it implies that the remainder term should be 0. That means 28 plus 14b whole multiplied by x minus 70 minus 14c whole divided by x square plus bx plus c is equal to 0. This implies that the numerator of the left-hand side must be 0. That means 28 plus 14b multiplied by x minus, within parenthesis, 70 minus 14c is equal to 0. Now x is a variable and can have any value. So, for the above equation to hold true for all the values of x, both the terms on the left-hand side of the equation must separately be equal to 0. That means 28 plus 14b whole multiplied by x will be 0 for all values of x, and 70 minus 14c also will be 0. Now, taking the first equation, because it should be true for all values of x, it should be true for x1. X is equal to 1. Therefore, 28 plus 14b is equal to 0. This gives rise to the value b is equal to minus 2. And the second equation, 70 minus 14c is equal to 0, leads to the value of c being 5. So once we know the values of b and c, we can find out the value of p1. In place of x, we put 1, giving rise to the equation x squared plus bx plus c being 1 raised to the power of 2 plus b multiplied by 1 plus c, which is equal to 1, and putting the value of b as minus 2, second term becomes minus 2, and putting the value of c as 5, third term becomes 5. Therefore, the total value becomes 1 minus 2 plus 5 is equal to 4. So, P1 is 4, and that is the answer.